Well, the last time we were together, we talked about what a reaction rate is. Today, we're going to talk about ways that you can increase the reaction rate. How can you make the reaction go faster? And the best way to understand the ways that you can affect the reaction rate are to think about it in terms of the collision theory. Now, the collision theory basically just says that in order for molecules to be able to react with each other, they have to collide with one another. And that collision, a couple of different things have to be true of the collision. First of all, they have to collide hard enough with enough energy to make the reaction happen. Secondly, they have to collide with the correct orientation to make something happen. I'm not going to go into a lot of detail about that because I sent you a link to another video that is a rather clever way to remember and to understand those two particular concepts. So I'll let that video kind of speak for itself. But those are two things to keep in mind. The collision has to happen with enough energy to make the reaction happen, and the molecules have to actually collide at the right orientation to make the collision or to make the reaction happen. So what I want to talk about today are the 5 different ways that we can actually increase a reaction rate. And I'm going to relate that to the collision theory for you. So the first way to increase the reaction rate is going to increase the concentration of your reactants. Now, if the whole goal is to make collisions happen, then if I put more stuff in the container, then the likelihood of a reaction or of a collision taking place is going to increase. You can think of that very similarly to the more people you have in a room, the more likely you are to run into somebody. So I think we talked about this before in our gas theories, when we were talking about gases and pressure and volume and temperature, and we said the more kids you put on a playground, the more likely they are to bang into each other as they're running around playing. Same type of thing here. The more molecules that I put together in close proximity, so when I increase the concentration of them, the more likely I am to have a collision. And that's really what all this comes down to. In order to increase the reaction rate, I have to increase the possibility that I'm going to have a collision. And also not just any collision, but a favorable collision. So here, I'm going to increase the concentration because that will give me more molecules to collide. Okay, so that will increase the possibility that a reaction will happen. The second one is very, very much related to this, and the author of your book doesn't mention this one, and it's likely because he's not specifically looking at reactions between gases. He's making things a little bit more general. But if I decrease the volume of my reaction vessel, then I'm going to have less space for the molecules to move around in, and again, they will be more likely to collide. So there will be less space to move in, which again will increase the possibility of a collision. Now, you should already be aware that to decrease the volume that a solid reactant or an aqueous reactant or a liquid reactant, to decrease the volume of the reaction container there isn't going to do a whole lot. You're probably already fully aware that if you try to just squish a solid into a smaller container, most of the time it's not going to work. I try to tell my husband that all the time because he'll take our leftovers for dinner and try to squish them into the smallest possible container. I've never been able to figure that out, but he likes to do that. And so if you have a solid or a liquid and you try to decrease the volume, likely what's going to happen is your reactants are just going to overflow your container. However, if you have gaseous reactants, it's certainly very possible to decrease the volume of your container, and so therefore that's going to put your molecules closer together. So while this one definitely is true, it's going to be true mostly for gases. Okay, so the third way that you can cause a reaction to happen faster is to increase the surface area of the reactant. Okay, now surface area, again, another word for math. Surface area is the area on the outside of something. In order for effective collisions to happen, the molecules have to be exposed to each other. And so if I can increase the surface area, in other words, if I can pulverize them, I can smash them, I can turn them into a powder, then I'm going to increase the surface area. And if you think about that, if you have a big chunk of something, all the molecules on the inside of the chunk are really protected, and they can't interact with anything that's outside of it, because only the ones on the outside are going to be able to have the collision. So if I take that chunk and I smash it up and I make it into powder, then all of the molecules are going to have a much more likely chance of being able to collide with some of the other reactants. So smashing something up will help it to react faster. Again, you've seen this, although it's not really a reaction, you know that if you are trying to dissolve a hot chocolate powder or a drink powder in water and you have big clumps, I mean, just kind of out of a natural thing that you would do, you know that you have to take those chunks and you have to break them up. Now again, dissolving is not a chemical reaction. We know that that's not true, but it's the same idea. The more surface area that you can expose, the more likely you are, the more molecules you are giving a chance to make a collision. So, in other words, you're giving more places to collide. Okay? So, increase the surface area. Fourth, you can increase the temperature. What's increasing the temperature do? Well, if you will recall, increasing the temperature means that your molecules are going to be moving around more. Not only that, they're going to be moving with more energy. And so when they collide with each other, they're going to collide with more energy, which again, the more energy you have, the more likely you are to have a reaction occur. So I am really here, I'm going to increase the kinetic energy of the molecules because I am going to increase the speed that they have. You are probably pretty aware that if you bump into somebody while you're walking, it's not too bad, but if you have two people and you're running smack at each other and you run into each other, like on the football field or the soccer field, you have two players crash into each other while they're running at full speed, injuries are a whole lot more because there's a whole lot more energy. So again, here, the more speed you have, the more energy there's going to be by increasing the temperature. That increased energy also increases the chances that a reaction will happen when they do collide with each other. Okay, so increased concentration, decreased volume if we're talking about gases, increased surface area, increased temperature, and I'm going to go ahead and give you the fifth one just to make a complete list, but we're actually not going to talk about this last one until a little bit later in the chapter. And that fifth way is to use a catalyst. But again, because we're going to talk about that later, I'm not going to go into any detail today. You'll just have to hang on until we get there.